This office building does not have an individual air conditioner for each room. Instead, it has one large air conditioner, which is part of a central air conditioning system. This is the outdoor unit where heat is released. Through the grill, you can see a large fan which blows air across the condenser coils. Inside the building, in this unit, are the cooling coils. A fan circulates air from the cooling coils up through the metal ductwork to the various rooms. In each room, there are two sets of vents. Near the floor are vents through which the cool air is blown into the room. As the cool air absorbs heat from the room, it becomes lighter and rises toward the ceiling. Having absorbed heat from the room, the air reaches another set of vents, where the air is drawn out of the room to be cooled once again. This animated drawing shows how the air circulates through the room. We call this process convection. Convection currents like these are also found in a room having an individual air conditioner. This is how warm air is brought to the air conditioner to be cooled and recirculated.
Hello, everyone. Thank you so much for joining us on Did You Know, the ESCO HVAC show. Today, we are hanging out with Eric Ruggles from Yellow Jacket. How are we doing?
Doing well. Yourself, Clifton?
I'm doing great. You know, from that intro video, when we talk about air conditioning systems, they really haven't changed as far as the actual fundamentals. You know, from that video, we're looking at moving air, we're looking at moving refrigerants. So we're looking at temperature and pressures along the entire system, very much the same way that we do today. But could you imagine being a technician back in those 1960s, 1970s, and the tools that they had to lug around with them?
Technologies have really changed, put it that way.
Absolutely. And, you know, for everyone joining, we love to know how large our community of HVAC and building science professionals is growing into. Definitely let us know where you're joining from. I've actually moved the mobile studio. So I am now in Coatesville, Indiana, about 35 miles from where I used to reside in Brownsburg. So headed out to Heritage Lake. And so we're actually set up right now. Actually, it's a decent day today. It's probably mid 80s and a little bit of overcast, but the solar panels are just having a good old day out in this open field. Eric, where are you joining from?
Bloomington, Minnesota, just south of Minneapolis.
Oh, okay. So what kind of weather are you having up there this time of year?
Again, mid 80s, nice.
Yeah.
It's been pretty humid the last few days, but manageable.
Fantastic. So part of what we're going to be spending time doing today, we're going to do some hands-on demonstrations. We're going to do a combination of classroom and hands-on. Because Eric, one of the things that we get calls on quite often, and it's a big topic at the National HVACR Education Conference, is how do we integrate smart diagnostic tools into the classroom? And as technicians, how do we properly use our tools? For a lot of instructors, like myself, when we came out of the field, most of the tools that we have today were coming into the industry. So a lot of educators are, you know, typically a few years out of the field. The industry has made a lot of transitions. And so keeping up with modern tools and technologies it's a daunting task if you don't have manufacturer education and support like we have today. And so that's really what we're here to do today. We're here to spend time to help you all get comfortable with the whys and understand that digital tools are not something that is coming. Like, digital tools are now the standard within the industry. And if we're not teaching it in our program, we're really doing an injustice to our students and to the technicians of tomorrow. So Eric, tell us a little bit about your background and the evolution of tools here with Yellow Jacket.
Yeah, it's fair. So I've been with Yellow Jacket about 2 years, just a couple weeks, shy of 2 years.
Awesome.
Before that, I worked for another major manufacturer in Minnesota that did heating and cooling of engines. And prior to that, I worked for a commercial HVAC manufacturer, both on the service and the engineering side. So I've kind of been around HVAC my whole career, and now working in the tool industry. The tool side of it is exciting and fun. And I'm really passionate about the wireless tools, about the advantages and the connectivity we can have with them, and how it can kind of grow and make it easier for techs in the field in the future. But also how the digital age has changed with the younger students in our classrooms have grown up with cell phones, and how they're going to be using them in the field no matter what. Let's teach them to use them in the classroom as well.
That's one of the struggles that we've encountered is, the educators going, you have to learn on the fundamentals, and then we'll teach you the digital later. And I do agree with that to a point. We have to teach the fundamentals. We have to teach where these temperatures and pressures come from. But I also believe that if you want to capture the attention of a student, as soon as you can get the opportunity, I'd like to, within the first few days, walk over to the diagnostic tools, right? Walk over to a complete refrigeration or air conditioning system. Let me walk over to one right now. This is the one we're actually going to be using here after a while, right? This is the Amatrol T7045 refrigeration trainer, right? So many of the classrooms already have pieces of equipment like this already set up. Well, we can use something like this that's already showing the mechanicals, or we can have mechanical gauges hooked up to be able to show what these temperatures and pressures are representing. But there's absolutely no reason we can't integrate the digital along with it so that we're showing all of it together at the same time. So today we're going to actually be doing this, and we're going to be integrating the system to show you what it looks like through the mobile app. So it's not difficult to integrate into the classroom. We just need to be able to get comfortable with what we're doing with those, and that's why we have our manufacturer with us here today. So, what do you think? Want to start with a little bit of the whys before we move into the hows?
Yeah, let's do it.
Okay.
So I did a bit of this presentation at the HVAC Excellence show last year. I'm going to probably do similar next year, but the whole point is, how do we integrate and why do we integrate, right? The biggest reasons we integrate is that times are changing. Back into history a little bit, electrification across the country was starting back in the early 1900s. And we got to radio and electrical appliances in the 20s, 50s, transistors came out. 1980s, internet was invented. 90s, we had World Wide Web, GPS was public. Again, 2000s, smartphones emerged, Bluetooth was invented, Wi-Fi was now a standard in most places, cloud computing. I mean, that's still 25 years ago, right?
Wow.
It's just, I think the last 40 years, it's just going exponential change, right? 2010, iPads were invented. We have tablets now, right? Smart home, streaming replaced the traditional media. There's an app for that era, if you will, right? Now there's an app for everything.
Everything.
And then you get to 2020, and now AI is starting to take over, and then there's things you're teaching it how to do things for you and beyond. So it's rapidly changing, right? So if we're not teaching some of these technologies in the classroom, we're not keeping our techs ready for the market that comes.
We just had this conversation internally here at ESCO this week. We were talking about new technologies and artificial intelligence and ways that technology is changing the scenery around us. And there's always definitely that stigma of change. There's always that I don't want to progress mentality. But at the same time, you have to realize exactly what we had determined as a company. If our competition and everyone around us is staying ahead of change and we are not, then we are going to be the ones that are going to suffer, and we're going to watch our competitors grow. And so that's why we're here, is to help you better understand this transition and be well prepared for it.
Agreed. Yep. Staying on top of technology, right?
Yeah, that's it.
Quickly moving on, a little history of Yellow Jacket itself, but we invented refrigeration hoses that you could just finger tight back in the 1940s, 1950s, moved on to analog gauges, vacuum pumps, etc. Back in 2010, we came out with the first digital manifold. 2015's smart digital manifolds, and now we have Bluetooth sensors and advancing the app and things beyond, which are all out there with many manufacturers, right? So if you look at other wireless Bluetooth sensors, there's the big brands, but Yellow Jacket's certainly one of them, right?
Absolutely is. I've had so many Yellow Jacket products over my years out in the field, and I've been very happy. I've still got a Yellow Jacket vacuum pump from, I don't know, late 90s, early 2000s, somewhere.
Yeah, I'll be honest. Service of the vacuum pumps is just outside my office, not too far. And we see pumps 20 plus years old coming back
Yeah,
all the time. We repair them,
exactly.
send them back. I mean, they still function, right? It's still a great piece of equipment. So
Yeah, I've changed the coupler on mine once, maybe twice over its lifespan, and that's pretty much it.
it's great.
Mhm.
Yeah, I mean, advantages of wireless sensors, they're small, compact. You can, carry a couple in a bag, in a pocket if you needed to. It's easy to access pretty much anywhere in the system. You don't have to stretch long hoses if you got a big system you got to attach to. Um, Obviously, you can get full system diagnostics if you're using air side and refrigerant side, which helps. And then no refrigerant loss in hoses. You can connect a pressure
It's
sensor.
huge.
Just the sensor is taking the refrigerant, right? Not a full 3, 5, 7 foot hose attached. They do require batteries. You are kind of limited to a Bluetooth range depending on the type of equipment you're using. And also a lot of them require apps. Some of them have screens, some of them don't have screens. That could be a benefit to some. Others, the app's more beneficial, if you will, right?
Mhm.
That leads me to the app side, right? Most of these come with an app or somehow linked to a Measure Quick app that can use multiple sensors, but you have remote troubleshooting capability, total unit analysis. So you can connect your refrigerant air sense and your air side sensors all at the same time, and then kind of review the whole system within just a few clicks on your screen. We have multiple sessions, whether you're doing pressure and temperature, the refrigeration, psychrometrics of the air, evacuation, leak testing, kind of all automated within the app. We can walk through that a little bit later.
Yeah, definitely.
Data logging capability, emailing, uploading, creating reports that you can send to either your supervisor or send to the customer themselves, et cetera, geolocation, invoicing, and then obviously this is where AI is going to come in on the app side on how do we diagnose and troubleshoot and help the technician improve his troubleshooting ability on the job site.
And that's this next generation of technology that we're moving into, where we're starting to gather all of this data. We talk about, cloud computing and cloud uploading. All that data is out there. So now we're starting to use processing power to sort through that data to help give assistance, not give replacement for technicians, but give assistance to the technicians. It's all about having a tool to make us more efficient.
Exactly. I used the example in the past that, technology's changed. We, did math on paper, and then we had slide rules, and then eventually we got calculators. Now you got plug it in your phone or iPad or whatever, it does the math for you, complex math problems if you need to. But again, we learned from the basics. We learned how to do addition and subtraction, long division or whatever, but now we're just utilizing tools. You're not going to go out in the field and not use a calculator on a complex equation when you have that access to the tools.
That's exactly right.
Well, as long as you know how it works and why it works, the tools are still just as useful. Looking at technology changes in the classroom, again, one of the whys. Why? Because technology is changing. Back in the 50s and before that, there wasn't such thing as trade schools. There's apprenticeships in all the fields, right? So beyond that, trade schools were established in the 60s, 70s. EPA became required in the 90s. Now we had more technology in the classroom from there, online videos, PowerPoint. 2010s, again, iPads, smart boards, online teaching tools. 2015s, personal computers and tablets for the students. Now in 2020s, we have virtual classes, since COVID era, app-based assignments, all that sort of stuff. You have assignments you submit online, et cetera. Times have changed significantly. I don't know why we can't walk into a classroom and say, pull out your cell phone, because we're going to do assignments on the cell phone today, and you're going to submit the report to me as your final assignment at the end of the day, and then I'll grade you on that.
We've actually got instructors that are starting to do that. They're using the smart tools in the classroom, and part of the assessment is the students going out using the diagnostic tools that are hooked up to a piece of equipment, gathering the data, and go, okay, where are we at? What's our next step? And I really love that we have those classrooms that are moving forward. And our goal here at ESCO and with HVAC Excellence is to move the classroom forward. It's all about better understanding the instruction that we're giving. And yeah, you're right, V3D, that it really is about understanding the system first, using the tools just to confirm. It's a great way to document our findings. Like one of the things that we'll do as part of our demonstration of how to use some of our existing trainers to be able to teach on, we'll be able to set up scenarios, even like adjusting airflow on the system while our smart diagnostic tools are connected to see what that outcome is. Or challenge the students to what happens if I do this. What would you anticipate? There's a lot of scenarios we can do with the equipment that we already have simply by thinking outside the box and using our diagnostic tools.
100%. Yeah, we can get to that. The last
Yeah,
one was the other why is the students are changing too, right? You know, the
100%.
analog age, baby boomers, Gen X, first to kind of use a computer. Millennials, obviously digitally literate. We grew up with the internet, cell phones, got more into the connected world. Social media was invented. The Gen Zs, now digital natives. So they grew up with smartphones, they grew up connected technologies. And now we have Gen Alpha, which are not quite to student level yet, but getting close, born with connected screens as part of daily life. At, you know, 2, 3, 4, they're watching cartoons on a tablet or whatever else. And it's just a different world that they grew up in than what we grew up in as from a technology standpoint. So we got to make sure we're staying up with that. That they might be smarter with us with a cell phone or a tablet than a lot of our instructors. That's okay to learn from them as well, right? We don't have to be the smartest one in the room, but if we can grow together, that's the whole point. We're using the technology and staying connected.
I feel like Gen Alpha, I've been doing a little research over the last couple of years on different learning habits of different generations. And Gen Alpha is recognized for being team technology players, right? They like to use technology to group chat, to group communicate, to be able to mentor and peer each other for a specific topic in classrooms. And we've got a few classrooms that have shared with us that they're now starting to do this as part of the in-class assignment for the students. Like they would all have the connectability to a system that has the smart diagnostic tools connected. And as a team, they get to actually communicate back and forth to be able to make the decision on what's happening with it. And it's really interesting to see that the power of digital communication is very relevant in Gen Alpha.
100%. And Gen Z, I would
Yeah,
argue.
Gen Z as well. You bet.
Yeah. So again, high level, why should we teach wireless sensors?
Yeah.
System thinking, right? Show the relationships of the full systems in real time. We're not just reading gauges, which link, you know, the pressures maybe, but we can see the live relationships. We can see superheat changing with airflow. We can see the head pressure reacting to condenser conditions. Supply return temps tied to refrigerant change or space loading, etc. in live time on the phone or on a computer screen or tablet, all the same with the full system, right? You can do that either live, you can do it remotely, you can see it on the roof versus and being in the building, in the load, etc. It's exciting.
And you can share the data, which is really cool.
Yes, we'll get to that too. Yeah. So again, we get goals to teach the students and to ask the question why, right? To get curious, to figure out and understand and reason a little bit more. The other advantage is we can visualize. You know, analog gauges are a snapshot. Digital is a movie. You get to see things change. We can graph in the app. You can watch things graph, whether it be pressures, temperatures, vacuums, etc. You can, you know, take a data log and then put it up in a graph of everything if you wanted to. But you can see trends. You can see the compressor shut off and turn back on. You can, you know, see what happens when it doesn't start and why things equalize, etc.
I love that analogy with analog being a snapshot. I hadn't heard that, but I really like that analogy.
Yeah, I mean, once you take your eyes off of it, it could change, right? You don't know what happened. So, yeah, just exciting. The other aspect of wireless sensors, you can do it in a shared learning environment, right? So the nice thing with yellow jacket sensors is it's always outputting the pressure. It's not a one-to-one connection like some of the sensors out there. It's if you have the sensors and you have a whole classroom connect to the same exact sensors on the cell phone, they can all watch it live on their own device versus having to have one local device that they're all watching on a separate screen, right? So they can all connect to the same exact sensors that you are, or you can set up different sensors for different labs or different units, and then they can connect to those individually for different assignments or lab scenarios, etc.
Yep. A question just came in. Osvaldo's asking, you know, how many probes are necessary to do a basic analysis? Well, we're going to show you here very soon, so hang in. We're going to do a hands-on demonstration here for you.
Yeah, I think we can probably shift to that here pretty quickly. I mean, the last reason why, from my perspective, is the goal is to build data-driven techs, right? Not guessers, not part changers, not just somebody that's going to let the equipment do it for them, but it's to trust the data, to document your findings, to defend their diagnosis of the equipment, right? It's to use it as a data factor to show and document what you did, not to, you know, as an excuse to exchange a part or add refrigerant or whatever else. So advantages, you can create commissioning reports, performance verifications, troubleshooting issues. The app allows you to take pictures, add notes, etc., all that you can add to a report and easily print out. for a class assignment or for, you know, customer, et cetera.
You know, there's a lot of things happening in our industry that we don't always talk about with smart diagnostic tools like this and digital instrumentation. I actually participate in a panel called Connected Commissioning, where many of our manufacturers and utilities are meeting to determine, like, what does it mean to commission an HVAC system, especially a high-performing heat pump? What is necessary for that? And it started out as a conversation where the manufacturers of inverters could spit the data out. And many of us rose our hand and said, you know, with the right technician tools, we can do the same thing. We can gather all of this data, just like you were doing with your temperature thermistors. That's exactly what we're doing with our wireless tools that our tool manufacturers are making for us. And so now we're going to be seeing a shift in our industry. Like in the next year to 2 years, there are going to be many utilities around the country that homeowner will not get their rebates unless they have a technician that has done a true commissioning report that's used the proper tools, because you can't manually input any info. It has to be completely generated report. And we can do that with this type of instrumentation. So a lot of things change in our industry that we need to be aware of and be prepared for. Oh yeah, California is a prime example. I mean, we're going to be talking about that heavy over the next few months.
Yeah, I've heard of manufacturers talking about requiring commissioning reports for warranty requirements, that sort of stuff as well. Yeah, absolutely. Mm-hmm. You connect the sensors and you take a snapshot or report, and then it's done. Like it saves you a ton of time on our end. So
yeah,
and it also makes you confident that your installation was solid and it's meeting the, you know, performance requirements that the equipment states as well, and we're all on the same page leaving the job site. So.
Yeah,
awesome. Well, the goal, right, we're not just teaching HVAC, we're preparing students to succeed in the real world, right? Capable in their skills, current with technology, and strong in critical thinking. And that's what I'm here for too, as well, with these sensors and trying to make them the best they can be. So, I mean, with that, I think we should move over to the actual unit, Cliff, and let's look at the sensors.
Absolutely. I will, I'll shift some things around here for us so that we can get a really good visual, and I'll have you guiding us around on this tour. I've got a few different cameras set up. And for those of you that are joining us, right, so the mobile studio, we had some upgrades since the last time many of you seen us. We're actually adding a variety of new pieces that we'll be talking about over the next few shows, but a lot more things to demo. Today, we're going to be focusing primarily on this refrigeration trainer. Let me get this is at 7045. And as you can see, we added all of our yellow jacket tools to that. Now, I'm going to have to probably bounce back and forth because every time I do hand motions, Eric, the automatic tracking takes over and grabs things. Yeah, that's exactly what it is. It's AI. It simply looks for some, I won't do them right now, but it'll look for some signals with my fingers, and it'll start auto tracking, and I can do controlled zoom. There's so many things that I can do, all because of AI. But we're going to try to stay focused right here. Now let's do a walkthrough, right? So what you sent me was, let me see if I can bring this up. You want to explain to the audience the products that you sent for us to do demo of today?
Yeah, absolutely. So I sent you the middle big box is kind of like the core requirements to do a standard analysis of a system. It's called the charging and air kit. So It's got 2 pressure sensors, it's got 2 temperature sensors, and it's got 2 psychrometers.
Excellent. So Osvaldo, you were asking what's our core kit? That would be the Y-Jack charging and air kit.
Yeah, we have a few other kits if you just want pressure and temp, or if you want, you know, add the vac to it or whatever, or you can buy them all individually.
You bet.
Totally how you want to handle it. I also sent you a vac, which is on the right there, and then a manometer up left.
Let's try to zoom in here.
I was unable to send you a few more, so I have those in hand on my end.
Yeah.
But we also have an amp clamp, which is nice for getting your current readings of compressors and fans. We also have an anemometer, so a hot wire anemometer, which you can extend. It actually comes with a magnet, so it can stick to the ductwork as well, so you don't have to hold it in place the whole time, which is really nice. And then you got the vac. So that's pretty much it.
Nice.
Overall wireless sensors, yeah.
All right, so with the ones that we have right now, let's do a walkthrough. Let's talk about like proper location for each of them, and then we'll go fire up the app. We'll show everyone how to connect them to the app and what type of data. So if we were to start with our wide jack charging kit, I guess we can start closest to me. Let's start right here.
Sure. So yeah, quarter inch fittings. You can get adapters for 5/16 if you need to, but they just screw on normal with the Schrader core depressor in them. They also have an auxiliary port on the bottom, so there's a T built into it, if you will, if you need to add a hose to actually charge or anything through the system. So it's nice to have it built in. But right there, all you gotta do is screw it on the Schrader core and then turn it on, which is the little yellow button on the blue screen.
Trying to zoom into that one for you, but nope. I'll just stay back here for a little bit.
Worries.
Okay, so that one's going to be, this one's on our low side. Now, we're also going to do one on the high side, right? So if I move over on the high side, it's actually tucked back in just a little bit. Now we can see it. This particular one on the high side of our system is right here. So this had been our liquid side, and so we've attached our high side over here. So that's given us our low side pressure, our high side pressure, just like we were attaching a set of manifold gauges, whether it was a standard set or a digital. So if you notice, like on this particular Amatrol trainer, we've got what represents our refrigerant pressure and our temperature and mechanical. But now we're going to be reading the same thing for digital. Now, temperature-wise, though, we need to add temperature onto this low side system. So we're actually going to add, tell me a little bit about this one.
So that's your psychrometer. That's going to the air side. It's got a long probe, 12 probe on it, and you're going to want to put that in your supply and return air streams so you can get your dry bulb, wet bulb, relative humidity, and dew point of your airs. So we can compare those, get the enthalpies, and actually determine what the capacity is of the system and what efficiency it's running at.
So on this particular unit, you can see here, this one is labeled as our evaporator. So I'm actually going to go ahead and put this one on the back of the system, right in front of the fan. You can't see the fan from your perspective, but there is a fan on the backside and a fan shroud so that we can measure our incoming air using our temperature, humidity, as well as on that supply side. Okay. So
you have temperatures for the system side as well, right? So those are pipe clamps.
Yep.
And then again, you're going to need to put it on the low side and the high side, similar to your pressure locations. Got them right there.
So here's our low side. Let me see if I can zoom into that one a little bit better for you. Right. So I went ahead and labeled this entire unit. And for instructors, this is a really inexpensive thing for you to do in your classroom on any of your trainers. Simple blue electrical wire loom and red wire loom so that I can mark the low side and the high side of the system. And then I left a section exposed so that I have my bare copper to be able to attach my clamp onto properly. So this particular one is on my low side. And then on my high side, right above it, on the liquid line coming out of that condenser, I've done the same thing with it. And so it's easy to be able to find a good location, and keeping those visuals is pretty handy. That way all of our tools are the same color. Because I've noticed too, Eric, with all of your instrumentation, they come with red and blue indicators for each tool so that you can mark which one is going to be used consistently on the low side or low pressure of each connection.
Yeah. If you want to, obviously you can switch them on the app pretty quickly, and we can show you how to do that. But if you're in a heat pump system, you don't have to physically remove and change the locations like you do with other ones. You can just switch them on the app and change what's reading. So then, when you go to heating mode or whatever, you can just switch the sensor locations on the app.
Okay. So another item that you sent for us to be able to experiment with is
the mano or the manometer, right? So we're taking our static pressures of the system, or looking for total static or pressure drop across specific components, whether it be coils or filters or the whole system.
So I'm actually going to do the same with it. I'm going to bring it around so that we're going to be measuring pressure now on our airflow as well, so that we'll be measuring across the evaporator. Okay. Is that it?
You are connected.
So that's the thing that we don't talk about enough. We had about 3 minutes of actually walking through everything that was required for this system. If I was unpacking all of these tools and boxes out of a van, it's probably going to take longer for all my mechanical instrumentation than it is for our digital. So it's really not a time consuming thing. Now, we are going to need to turn these on and then connect them to the app. So I've got our Yellow Jacket app already set up right now. How would I connect these tools to my app, Eric?
You need to turn on the sensors. So the little yellow button on each sensor, push it for about a second, and then there'll be a little blinking light. Yep, there you go.
Okay.
So now it'll blink a heartbeat over time, but it is now live and transmitting.
Okay.
And then you all the sensors, and then you can go into your app. If you put the bottom left button, oh yeah, sorry, yellow HVAC View app for those that don't know what we're talking about. So this is the HVAC View app. If you click the HVAC logo on the top, the yellow logo up top, that takes you to the home screen.
Okay.
So you have your hot buttons if you want to go there, but then they're also on the bottom left. So if you're on a mobile device, quick access for your thumbs. The bottom bar is your quick hotkeys as well. So that kind of radio signal button is your devices. So if you click that bottom left button, you'll go to all your active devices. So these are all the devices that are within Bluetooth range of your device right now. If it's red, it means it's no longer connected. So if you swipe down on the screen, all the way down, like, yep, swipe down a little bit further, pull the screen down, it should refresh.
Okay. So I've got at least one. So I've got my manometer offline. And I was working with these earlier, so it makes sense that some of them have shut down. So we'll go back through, allow them. Oh, it's already reconnected. Cool. Okay. So it's just simply a matter of turning on our tools, allowing just a couple of seconds for them to connect. And now all of our instrumentation is reading. Now, you did mention earlier, some tools have actual screens and some do not. And I do like having that on my manometer. But the rest of them, if I'm already using my app, really all my data is going to be right here anyhow. So where would we start from here?
So the second hotkey on the bottom, the second one in from the left, is your sessions. I'm gonna have you hit it again to go back to the main session screen. So this allows you to pick what session type we're working on, right? So the upper left one is pressures and temperatures. So to look at your refrigeration stuff, let's go there. And then right now it's blank because we have no connected sensors. So you're going to click on the low side, one of the blue bubbles, and then you're going to pick which sensor. That one of the top two. Click the radio button of the top two, one that's low. You can look on the back of the sensor to find the serial number. You want to do it that way. If the system's running,
I may do that. Yep. Let me walk over here. I'll look on the back. I'm just going to swivel this one around. 9104. Yeah, there it is. So 9104 is our actual low side. So I would pick that one.
The radio.
Oh, there we go.
And then I like to go to the analog gauge, the middle. Yeah, I think it's easier to see. It's kind of what we're used to from an analog, but you can do any of those. So it's the line graph, a large number, or an analog gauge. So you can view that sensor in any of those. So hit save. And then we're going to do the same for the right side, the high side.
And once these are all connected, it's actually probably going to be grabbing it all the time for us, right?
Correct.
Yeah, I haven't did a complete setup with this set yet. Okay.
And then same thing for the temperatures. Click on those boxes. We've got to connect those temperature sensors. Looks like you only have one that's talking, right?
Okay. So which one have I got here? That one. Oh, that one's flashing. So I must have turned this one off. Okay. And so on my low side, that's going to be the 9623.
Should pop up, but you could cancel out of that. Assign the high side while you're waiting.
Yeah, there we go. Oh, now it's in. All right. So my high side one was the 9711, which would leave my 9823 for there. Okay. Cool. All right. Now where we go?
Looks like it didn't. Did you hit save?
Oh.
Oh, it's not recording it.
Oh, I may have hit that button too many times. There we go. That was on me.
All right.
I think I did it again. Hold on now. I think I'm holding it too long.
Yeah, you should just need to push it.
Yeah.
So now we have pressures and temperatures. Looks like your
Sweet.
system's equalized, so it's not operating right. So temperatures are the same, pressures are the same. Superheat and subcooling don't really tell you anything at the moment because it's not operating.
Right.
But at the bottom of the screen, it's hard to see with the camera at the moment, but there's system targets, and that's your system targets superheat and target subcooling, right?
Yep,
so
absolutely.
You've got a nameplate of a system, or what you're typically doing for a type of product. On the superheat target, you can actually use an input, which is the bottom one, or you can use a fixed calculated superheat value. In that case, you can actually take the indoor wet bulb and outdoor dry bulb from your psychrometers.
Yep.
And then that will auto calculate.
It'll calculate it.
The nameplate is based on specific conditions, right?
Yeah.
But if it's an extreme condition, those superheat numbers are going to be off, right? So you want to use it for the actual conditions. You can do it calculated based on a fixed value.
That's fantastic. Yeah, because depending on metering device, that's going to be, quite a variance.
Exactly. But obviously, TXV, EXV, you're going to have to put in because that's going to auto correct for you.
So we would just pick on that one. Let's just say 10 degree.
Perfect.
Okay. And let's just go ahead and do a subcooling. And just for consistency, we're just going to do the same thing. Right. Just for this particular experiment. Yep. Okay.
So the other advantage that's on here that maybe isn't typical for a lot of techs, but those that are commissioning a lot of units may have a number of sets of sensors that are setting up multiple sensors at the same time. So at the top of that screen, it says session 1, kind of in the large bubble. If you swipe to the left, you can jump to another session. Oh, the whole screen, just in the middle of the screen. Other way.
Or that'd be the right.
Yeah.
Oh.
So you can connect another set of sensors, and then you can swipe back and you can relabel those Unit 1 or RTU1, RTU2, or whatever you're doing. You can do up to 4 sessions at the same time. Same with the psychrometer session when we move over to that. So it allows you to work with multiple sessions if you have multiple sensors that you want to do, or you have a Titan Max or other digital manifold hooked up, and the sensors on the other unit, you can do multiple units at a time, which is kind of cool.
Very intriguing, yeah. Especially if I'm doing, like I said, multiple unit startup at the same time. We got multiple technicians. I can actually watch everything simultaneously. All right.
And classroom environment similar, right? If you have
exactly.
And you have different sets of sensors set up, you can set them all up individually and then just swipe between them.
Oh, wow. Yeah, in the classroom. So for the educator perspective, if you think about that, if I have enough tools, I could set up 4 different systems in my lab, and my students can actually do all the diagnostics from the classroom on each of the 4 systems. I could break the students up and have each of them working on a particular unit, rotate them around.
Exactly.
I love that. I've not seen that before, so that's really cool.
Yeah, so that's all set up on the pressure and temp session.
Okay.
Obviously, you turn the system on, you'll be able to see it fluctuate and see where it dials in at. You can change the airflow, you can change pressure, you can add a restriction in the system, whatever to make it get live readings. The other minor or unique thing about our app is that you hit the plus button in the bottom. It allows you to add a note, a picture, or take a snapshot of the session at any point in time.
Oh, cool.
And automatically create a report. So it'll tell you need to create a report. So what does the customer job go to? What is this report? So then it'll ask you to create one and put in all the details of all of that stuff.
Okay.
So it's asking for a customer name, a phone number, a job name, and a job address, right?
Sure.
So basic information of your job. And then you can have as many jobs and customers as you want, and we can, sort by those. And then within each customer and job, you have reports. And in those reports, you can have 1 report, you can have 300 reports for each customer and job, depending on, if it's a report by unit or a report by job site visit or however you want to do it. But yeah, just
Yeah, this would be great for the classroom if I have different units with a variety of different refrigerants.
Yes.
Okay. Where am I here?
Hide the keyboard somehow.
Yeah. All right, let me get back. Whoop. Boy, I really messed up now. There we go. Okay.
And then,
So we'll save all that.
Report, multiple sections, and you can add sections from there, and then that's how it goes. So, okay. But yeah, it'll take a snapshot of the current readings. If you're just in the session, so you can take a snapshot. If it's doing a test, like a vacuum test or a leak test, or picking an anemometer session with different airflow readings, duct traverse, except it'll spit out the reports. When the test is done, it'll ask you if you want to add it to a report. Then you can add those results.
So you could actually have a complete student assignment and assessment just from here.
Yes. Yep. They can email you the report when they're done of the whole scenario, and then they can add a note in the report saying the result is, or this is the problem, and that's the assignment.
Okay. Love it. What's next?
All right. So let's go back. Hit the button to go back to the sessions. The main session button. The second one in. You can go back. Yep, that works too. Then go up the upper right, the psychrometrics.
Yep.
Connect those two DO sensors, the psychrometers.
Okay, and let's see. On this one, we'll be using
the long ones. Yep.
9452. We'll be using that one.
So this is broken between supply and return. Yep.
Okay.
And again, this is going to show you the relative humidity, dry bulb, wet bulb, and dew point. That's what's coming from the sensors. If you scroll down, it'll show you the enthalpy difference.
Look at that. Okay.
And we're using that to calculate capacity. So if you put in the volumetric air, so if you click on that blue box, you can either input the volume of air that is, or the fan's supposed to be doing, or if you use your anemometer, it'll show the last 3 anemometer readings.
No kidding.
Actual
okay, true calculated airflow then. All right. Nice. So we'll just do, we'll just pick a random number on this one. Okay.
That's fair.
And for those that are wondering why there is different enthalpy between our supply and our return, I actually have our ductless unit running, our Daikin ductless unit running at the front of the studio that is blowing air across that would only be hitting this area. So there is a difference between the air behind the unit and in front of it. I'm sure I'll have those questions.
That's fair. And then you would add this capacity as well, the red box on the right, a rated capacity of the system.
I'm just guessing on this one. We'll say that's I don't know what the BTU is of that one actually is, but we're going to guess that that's around, let's just say it's a 6,000-ish. Okay.
Right. And then it'll use the difference in enthalpy and the airflow to calculate the actual capacity of the system, and then give you a system efficiency number based on what it's actually running to the rated calculation.
Oh, okay. All right. Getting closer. Getting excited now. Okay, what's next?
Then the last one is what you have hooked up would be the manometer. So if you go back out to the sessions, bottom right is static pressure. You're on the right. And then, you just have to find the one sensor. It'll show you both red and blue.
Got it.
And then it'll show you active pressures and the differential.
Okay. Now, what if I was wanting to do a reset of my manometer to 0 it?
Yeah, absolutely. So it's actually got a function to do that in the app. If you go, you got blurry on me there for a minute.
Sorry. Oh, wow, that did. It's like my autofocus went crazy. There, it's a little bit better. Okay.
You go back to the bottom left hotkey with the available devices.
Hold on a second. My auto went crazy on me. All right. The bottom left. Okay.
And find your manometer. Scroll down to find your manometer. And there's a little gear key on the right side of that blue bar at the top of the manometer one.
Step back for a minute.
Little gear logo. Yep. Click on that.
Ah,
And then it allows 0 pressures. There you go.
perfect.
So you should be able to go back to that session and it should be zeroed out.
Okay. Cool. Okay. Now where?
Yeah, so this is going to show, so if you're going to take multiple readings across the system, you can do differentials, you can do, ambient pressure to inline stream pressure, however you want to do it. We saved a few options in there, so you can hit hold on a reading and then go and scroll down and say, this is your filter pressure drop, or this is your coil pressure drop, or this is your total static pressure, and you can save those. And then you can, again, hit the plus sign, hit save to report or snapshot, and it'll automatically save those readings to your report that you saved.
Love it.
You can also use gas pressure and other readings on there. So
yeah, absolutely. Yeah, so you can use your one tool and just repurpose it for different applications.
Absolutely.
Okay. All right.
Yeah, so we can walk through the other sessions, but this is all hooked up for what you have there. So yeah, we have evacuation, which is your vacuum pump, which has a, for the vacuum sensor that's digital. So it'll record your micron reading as you pull down a system, and then it'll ask you what level you want to get below, how long you want to be there, and then it'll run an automatic decay test for however long you want to run it. It's below that level, then it'll spit out a report whether you pass. Typically that's graphing, so you can see it pull down all the time, which is exciting. You can also see if it rises.
Very important.
Off the vacuum pump and start the decay test. So same thing for the leak test. That would be typically a nitrogen pressured leak test. And then it's also, you can either use temperature compensation or not. So if you have a pressure sensor and a temperature sensor, you can use both of those to get up to the system, and it'll do the full test for you as well. Picking what your acceptance level is of leak or pressure change. Electrical session is with the amp clamp. So if you click into that one, if you have this on a system, it'll show you basically what the amps are reading. It'll also show you an inrush. If the compressor jumps on, how high that is. It'll track your maximum and minimum values during the whole session. And you can take a snapshot of those values and add it to your report as well. So you can typically take a snapshot of the compressor, take a snapshot of the condenser fan, the evap fan, show what they're doing. You can add in here the voltage. So then it'll automatically calculate what the power is running and then how much, that's actually running on the system. Then it'll auto calculate, how much energy that the unit is running. So that helps you with the efficiency overall as well.
Okay. I like it. All right. Are we ready?
Yeah, go ahead. The last few in there is your charging and recovery. So that would be a connected wireless scale. You can track your charging or your recovery of quantity of refrigerant and save that. The anemometer session, again, is with a hot wire anemometer. It literally asks you what size the ductwork is. It'll tell you how many traverses it has to do, how far apart they are. And then all you have to do is click the button on the sensor itself. And once you have those, and it'll walk you through each time, and then it'll spit out the volume of air as well as the feet per second of the actual airflow. And
there's like a half a semester of classroom activities right here in the app, by the way.
Yeah,
there's some really good stuff.
The last one on the bottom is the combustion analyzer, and that's with the combustion analyzer. You can get that report, the combustion analyzer, so that you have that in the report for the customer as well.
All right, there's for our gas heat classes.
Yeah.
Awesome.
So we can run your system, and you can change it and show how it works. If you want to do that, let's jump right in.
So where would we start from here?
I would jump into the pressure temperature session, so you can see the refrigerant side.
Okay. And we'll go ahead and fire this thing up. Keep my fan speeds down a little bit for a second. There we go.
You can see the high side going.
And this is where it's a great opportunity to show, our mechanical and our digital at the same time. Our students have that chance to be able to see what's happening on the physical trainer, see the manual gauges operating for pressures and temperatures, but also be able to read them at the same time. It's a good visual to recognize what we're doing here is no different than what we're doing here. It's just displaying it in a different way for us to have that continual tracking of information. Okay, cool.
So
I'm going to let that run for a little bit, and I think what I'll do is I'll zoom on that just a little ways That's probably pretty good right there. I'll come on back to our main screens, see if we have any questions from anyone in the audience, or if there's any other topics we need to grab, and then maybe we can move on to what all you have going. Yeah, so as Valdo says, you can see the more that we add to it, especially when we start doing our airflow, once we start looking at the psychrometrics of our system, it gives us a better calculation of the total performance and operating parameter. Oh, that's not fun, Kendrick. All right. So tell me a little bit more then. So you mentioned you have some other tools where you have our amp clamp, things that we can add to it.
Yep. So the amp clamp, again, measuring your compressor amps, your fan amps. I mean, I think that's critical when you're trying to figure out if there's a problem in the system, whether it's refrigerant side or air side. You can really tell a lot, understanding if the motor's running to rated load amps or not. Your compressor amps are supposed to be 12.5 and it's only running at 7. There's probably a problem with the refrigerate side of the system. If your fan amps are supposed to be running at 4.5 or whatever, and it's only pulling 2 amps, there's probably some sort of air side system, whether it's with the fan or with a restriction in the duct, dirty filters, etc. That there's something you need to think about. So I think it's important to look at a refrigeration system from the whole perspective, right, holistically, rather than just refrigerant gauges being hooked up. The other advantage we have, obviously, I don't know that I sent you a digital manifold, but we have the Titan Max, our most recent digital manifold. It connects with these wireless sensors as well, but also has hoses that connect directly to the system. If you want to charge through the system, charge through your manifold, or just connect to the manifold to the system as well if you need to. Certainly, you can use the temperature clamps, or you can use the ones that are wired to the back of it. It connects to the dews, so you have the psychrometer session as well, right on the Titan Max. So it's useful as well. It's all connected. I can take pressures and temperatures directly from that into the app, rather than having to connect to 4 different sensors as well. So that's kind of handy.
One of the things that you had mentioned is how artificial intelligence is starting to look at data. What type of solutions are we starting to see from that data, from the app? Are we getting recommendations for technicians? Are we getting prompts for things to look at?
Yes, we've so far shied away from it because these sensors are so universal. They can be used on any type of system, right? I can connect these sensors to a standard residential split system. I can connect them to a massive chiller. I can connect them to a VRV or VRF system. Very different numbers, very different readings, possibly different recommendations of what needs to be done. So I don't want to give the wrong recommendation for a technician that's relying on it. I want them to figure out the problem versus them relying on something from an AI. We're working on solutions to develop, what type of equipment it is, where you're connected to the system. Then we can help give you better recommendations. But if I just tell you, hey, your pressure's high, your pressure's low, your temperature's low, you probably have it undercharged. I don't want to be responsible for that, giving you false information.
I don't either. Get all the data, and then let's get together and talk about it. Katie has a really good point. Katie is a top educator from Missouri that is asking, how long does it take for, particularly like the instructor, to get comfortable with the equipment and the tools? And so I can tell you, Katie, I just received these tools. I had never used the Yellow Jacket diagnostic tools before. And I literally connected these up a couple of hours ago. That's why there wasn't any of the data on the app. I had not connected anything to the app yet. I turned them on just to make sure that the batteries worked. And then we went through the entire demonstration. That's why we wanted to walk through this with our manufacturer to be able to show us what these do, how they connect. So for myself, within an hour, I got pretty cozy with connecting everything and seeing how it connects into my app. Now, moving from there to assigning it to students, that's going to take a little bit more time, but it's really not a lengthy challenge. It seemed to flow very comfortably, especially if I'm using equipment like my refrigeration trainer. Like, I'm very comfortable with all of my mechanical gauges. No big deal. We know where the digitals are supposed to go. Just put them there in the same location, and now you're going to be getting that same data. And so it's more about breaking through that uncomfortable barrier of change. We know how our mechanical gauges would connect. Well, we're doing the same thing with digital. We're now just using that data to be able to get more use out of the data that we previously collected, and reducing the amount of refrigerant that we're leaking to the atmosphere every time we connect those gauges.
Yeah, and I think to Katie's point, it's more comfortability with the app and what can the app do? How do I connect to the app? How do I make the students connect to the app so we're all seeing the same thing? Troubleshooting them using their own cell phones or tablets in the classroom. That is a challenge that we kind of have to get familiar with, and how to instruct students to use them and connect properly versus goofing off on their phone or whatever else. That's kind of the learning curve we got to navigate. Totally understand that concern. The other thing, which we don't really have a whole lot of time for, but we're developing an app. I have beta testing it with a number of universities across the nation right now, but it's called the Trainer app, and I can actually create my own sensor data that I can send out to my classroom, and then I can make scenarios that they have to troubleshoot remotely, basically just on their phone. This is focus of this is to help them get used to comfortable, you understand the app a little bit more, but also I can use it for systems and scenarios I can't simulate with equipment in my lab. I don't have the equipment. I don't, flammable refrigerants, whether it's a massive system, whether it's something different, scenarios that aren't easy to simulate without damaging things. I can make those sensor data on the tablet and then send it out to the students, and they can see it live and troubleshoot and figure out the problems that way as well. So,
I'd love to demo that. I'm a nerd for my digital information and being able to manipulate inputs to see what our output is. That's a lot of fun, and really in the classroom it's something that you can do manually, but it would be nice to be able to control that remotely. If you have scenarios where we have remote classrooms, completely remote, and you don't have equipment in your lab, this is what helps you be a flexible instructor. You could be sick. A student could be sick. We could have another whatever happened to society where we can't get in front of the physical equipment. But what if we can teach virtually the things that are happening? If we teach those fundamentals, prime example, what happens when I reduce airflow on an evaporator? If we're asking it of a student, right? It's one thing to be able to go over to a piece of equipment and go, okay, let's close that. Let's shut that airflow down and let's go see what this thing does, right? We could fear, we could sit and watch. We'll eventually, most of us know what's going to end up happening to this thing. But it's one thing to be able to explain that to the student with a piece of equipment, but what if we can't? What if we need to do the exact same thing digitally? It's literally a matter of, I know as an instructor what's going to happen when I reduce this airflow, but now if I've got a simulator, I just reduce the airflow and let the formulas take over. Ooh, that's an exciting tool for a classroom, Eric.
Yes. Yeah, we're excited about it. We'll have to do another podcast in the near future to have you demo it, show as well. It's teach them how it works and what you can do with it. Set up scenarios of different types of refrigerants, different types of equipment, etc. So, yes.
This is why we do this class. We want these sparks to happen. We want these light bulb moments to go off, because you could now take a tool, do the same job that you've been doing, but now actually generate a report for that customer so that they can see what's actually happening. They don't have to take our word for it as the technician. We can actually prove, what if you did this when you started and then when you're done servicing?
Exactly. So a lot
here's
of
your
our
investment.
Reports, here's your initial, when you get to the job site, here's my readings, and then you prove the fix or take a picture of the leak or whatever, the fix portion, and then you take another reading at the end of the system and you prove that you've solved the problem, right? And the customer can see it and save it for future assignments or problem technician. Exactly. So.
Give me the documentation. Oh, no problem. Send.
I'd love to walk through that. I know we're running out of time, but that's the other stuff we can walk through and show them exactly, how to do that process. It's not difficult. It's pretty intuitive, but again, setting it up, it takes a few minutes to walk through all the little steps.
I think we should do that. What about all of you in the audience? Do you feel that would be a good conversation to do very quickly as an overview, or do you rather have a separate episode where we dive into all of the capabilities that you can do for documentation and for reports? Because I feel like we could probably spend some time going over that.
Absolutely.
Wait a second for them to come through. We're actually at the top of the hour. I'm sure I know the answer is going to come through with all of that. All the innovations and the technologies that are coming to Yellow Jacket?
Yeah, obviously our website is kind of the whole sole focus. There's obviously a channel on YouTube as well with, how in use videos of where to connect, how to troubleshoot, how to use the app. We do have some local reps in most regions that will be able to teach you as well, but you can find those on our website as well with the local distributors and that sort of thing. We do have an education program that our sales team can help support, some savings on equipment as well as potential future trainings as well.
That's a big deal. All right. Well, I think we need to get together sometime. We'll schedule a second episode where we dive into all of the capabilities that we have through, through the app. I think Katie's ready to just keep on rolling. Well, we promise that we will, Katie. We'll plan another episode where we can show you as an instructor how to use the app in your classroom. I think that would be a pretty significant class and course for us right there.
I agree.
All right. Well, thank you so much for joining us today. We're glad everyone got to spend some time. I'm glad I got to hop in front of a piece of equipment. I've been looking forward to getting everything moved and set up so we can start doing more of these hands-on classes for you. And we look forward to seeing you all again next week on Did You Know, the ESCO HVAC show. Bye, everybody.